Hi, welcome to the video about domains of functions. So a reminder from class, we talked about the domain being all valid inputs. So here's some more examples that we're going to go through. Here we have the function d of t is equal to 45t. Let this represent the distance traveled after t hours when you're going 45 miles per hour. So the question is, what are the valid inputs to this function? So a reminder that the inputs here are the values of t that make sense for this function. So t represents hours. What's valid? Well, certainly 3 hours is valid, 5 hours. In numbers, fractional hours, 0.5 hours. Is 0 hours valid? Yeah, you could not go anywhere. The distance would be 0, but negative time is not a valid number. So we want to say that the valid inputs to this function is when the time is greater than or equal to 0. So right now we're just giving a verbal description of what the domain is. We'll talk more in the next video about how to write that in interval notation. The next function we're going to look at is an average cost function. So here we have c of x representing the average cost for making x burritos at a food cart. What's the domain of this function? So again, we have to consider what kind of inputs would we have? So what the input is x burritos. Well, how many burritos can we make? So again, if this is our input, we have to look over here in our sentence. That's where we see x burritos. Well, we can certainly make 10 burritos or 100 burritos. We can't make negative burritos. So like the previous example, we would not allow negative values of x. Can x be 0? Well, certainly in real life, you could not make any burritos. But in this function, if I have an input of 0, let's just evaluate this. What happens? We have 4 times 0 plus 2,500 divided by 0. And right there is our problem, dividing by 0. It doesn't matter what the numerator is. This becomes 4 times 0, 0 plus 2,500, so 2,500 divided by 0. This is undefined. So that is not a valid input for this function because we cannot divide by 0. So here, the domain of this function are all values of x that are strictly greater than 0. And if we want to be really technical, we wouldn't have fractional burritos that we would make. So we would really be just the integer values starting at 1 and moving forward. We won't be that technical at this point. We'll just say the domain, so again, a verbal description, are values of x greater than 0, simply greater than 0. We cannot have 0. So now we're going to look at just some algebraic problems and think about what the domain of these three functions would be. So in our first function, f of x is equal to 3x plus 2. We want to think, what can we plug in for x? What kind of values can we look at in this function? Certainly I can plug in 0 because 3 times 0 plus 2 is valid. We can do that. Certainly I can plug in all positive numbers. I can plug in 1 million, positive 1 million. 3 times a million would give me a value, and I can add 2 to it. Certainly negative values. I can plug in any negative number, multiply it by positive 3, and add 2 to it. So in this function, the domain is all real numbers. And again, these are just verbal descriptions. We'll come back and figure out how to write that in interval notation. Here, g of x being x over x plus 1, what kind of numbers can I plug in for x? Certainly, most numbers are all going to work. But like we saw before, if we have a problem where there's a denominator, and we have x in the denominator, that can never be 0. So x plus 1 cannot be 0. Well, when is it 0? Well, this is an equation with a not equal to symbol, and I can solve that. I can say, well, I'm going to subtract 1 from both sides, so x cannot ever be negative 1. But it can certainly be negative 2. If I substitute f of negative 2, or if I evaluate at negative 2, I get negative 2 over negative 2 plus 1, and that's negative 2 divided by negative 1, which is a positive 2. So I can certainly evaluate for negative 2. Likewise, I can evaluate for 0. So just to kind of look at this, what happens if I plug in 0? I would have 0 over 0 plus 1, which is 0 divided by 1, which is 0 in the numerator is okay. 0 divided by 1 is 0. So 0 is a valid input. It's when we plug in f of negative 1, which we have seen from this work that we did that that's not valid. Why is it not valid? Because negative 1 over negative 1 plus 1 is equal to negative 1 over 0, and that is undefined. So here, all of this work shows us that the domain is all real numbers. All real numbers, except x cannot be negative 1. And that would be how we would describe the domain for g of x equal to x over x plus 1. Okay, let's look at our third example. H of x equals the square root of x. So let's think about this function, square root. What does the square root do? When can we not take the square root in the real number system? Well, we have a problem when we take the square root of negative numbers. We end up with, in the imaginary numbers in the complex number system. Again, more on that probably another term. But certainly anything that's positive, I can plug in h of 4. For example, square root of 4 is positive 2. I can evaluate this at 0. The square root of 0 is 0. So 0 is okay, but it's when I plug in, when I evaluate at negative 1, that we are no longer, this is not a real number. It is a number, just not a real number. And right now we're talking about real valued functions. So we need to describe this domain as being any number greater than or equal to 0. So the domain here is when x is greater than or equal to 0. Or you can describe it verbally and say greater than or equal to 0. Okay, so to recap, here's 4 important points to remember when you're thinking about finding the domain of a function. To find the domain of a function, you want to start with all real numbers. You're going to assume that everything works until you kind of restrict things. So then we'll find the restrictions. One restriction might happen if the function has a denominator. So you want to exclude any numbers that make the denominator 0. So I'm just going to abbreviate, make the denominator 0. Okay, and we had an example above of g of x when it was x over x plus 1. So look at example number 2. Another thing that we will see are square roots. And we want to exclude any numbers that cause the expression under the radical, not necessarily the x, and we'll look at more examples in the next video about this, the expression under the radical to be negative, or so negative, or you might say less than 0. We don't want it to be less than 0. And the last thing that you want to consider when you're making a restriction is if it's a word problem, then we might need to restrict the domain to what makes sense. For example, when we were looking at the distance function at the beginning of this video, we wouldn't want to talk about negative hours of traveling, or for our burrito example, the average cost of the burrito, we wouldn't think about making negative burritos. So that might restrict parts of your domain. Okay, what I'd like for you to do is to try these problems before moving on to the next video. So the directions here: describe the domain of these 3 functions. Number 1, f of x equal to 1 over x minus 2. Second function, g of x equal to the absolute value of x. And the third function to describe is h of x equal to x squared. So think about those functions. What are valid inputs, or what are valid x values to evaluate the domain before moving on to the next lesson?